So we're on magnitude or modulus of vectors. So the magnitude or the modulus of a vector is just the length of that vector. So another name for magnitude or modulus is the length. And how do you get the length of a vector? It's simple. Once you know the x component and the y component, the square root of the sum of their squares. Yes. So assuming you have a vector, vector AB in this direction. So assuming we have the x component to be this, let's call it x, the y component to be y. So the length of this vector is what we are asked to find, which is the magnitude. We normally denote it. So assuming this is A, if this is vector A, so we always denote it with absolute bar. So that's it. So the absolute of AB from our basic triangle theorem, you know this will form a right angle triangle. So if you want to get this, is now square root of what? X squared plus y squared. So by Pythagorean theorem. So where x is the x component, y is the y component. So example, if someone asks you to find the magnitude of, maybe you have a vector, a column vector, maybe -2. So the answer is very simple. The magnitude or the modulus is now square root of -2 squared plus 3 squared. So that gives us 4 plus 9, which is 13. So the magnitude is always positive. That's why it's absolute. Or maybe if you ask to find the magnitude of a vector written as a unit vector, maybe it's 2i minus 3j. The magnitude is simple, square root of what? 2 squared plus minus 3 squared. So also get to 13. So the magnitude of modulus is the length of the vector. So once we hear magnitude, it means the length. So let's move to. So the next subtopic is multiplication of vectors by scalars. The result of multiplying a vector by a scalar is another vector, will form another vector that will move in the same direction as the original vector or in different direction. So if k is positive, it will move in the same direction as the former vector. But if k is negative, it will change direction. As you can see, we have vector A. So when we multiply by k now, the scalar k, so it will increase in magnitude. You see the length. I told you the magnitude is length. Ka. But if you multiply by a negative scalar with the same magnitude, maybe k, you see that it's the same in length but different in direction. So that's it. The effect is either it changes the direction and also increase the magnitude, the length of the original vector. So that's the effect of multiplying a vector by a scalar. So look at this question. They said if m, that's given vector m to be this, column vector m to be that, n is that, and r is that. They said if r equals alpha m plus beta n, where alpha and beta are scalars, so they are scalars, express n in terms of r and m. So let's draw a line. And see, this will form a simultaneous equation. So let's solve. Remember, we're asked to express n in terms of r and m. So in our expression, we'll see n, we'll see r, and we'll see m. And n will be the one to stay alone. That's the subject of formula. That's why they say write n in terms of r and m. So n must be equal to something r and something m. So let's read. They gave us r to be equal to alpha m plus beta n, and they have given us vector r as 17, a column vector, and also we are given this alpha is a scalar, so it's multiplying m, which is 5, 3. Y beta is multiplying -1, 2. So we multiplies, this is okay. So alpha will multiply both the x and y components. So alpha times that is 5 alpha. Alpha times that is 3 alpha. Plus this is minus beta. 1 times that is minus beta, which, and also this is 2 beta. So what do you have to say here? This is the result. That's vector 17, 5. That's the component 17, 5. So what do you have to say? Common sense will tell you that the one of the s component of this will be as the result of the sum of the s components of these two, the ones on the right hand side. So we have 5 alpha plus minus beta, which is minus beta. So that's our equation 1. Why the one here? The y component will be equal to the sum of the y components of the ones in the right hand side. We'll call it equation 2. So we'll have a simultaneous equation, and the best way is to eliminate, and the one that seems to eliminate faster will be beta. So I have 2 plus 2 beta here. Let me multiply equation 1 by 2 so that we'll eliminate by adding. So 17 times 2 is 34. 17 5 alpha times 2 is 10 alpha. That times 2 is minus 2 beta. So let's call it equation 3. That is, I did equation 2, equation 1 times 2. Call it equation 3. So we'll focus on equation 2 and 3. So we want to eliminate beta, we'll add equation. So adding equation 2 and equation 3. So we'll have that 5 plus 34 is 39. 3 alpha plus 10 alpha is 13 alpha, and plus 2 beta plus minus 2 beta is 0. So what do you have to say? Alpha is 39 over 13, which is 3. So we've gotten the value of alpha. So let's choose any of the equation and substitute the value of beta. And the best one to choose is equation 1. So from equation 1, you see that making beta the subject of formula is now 5 alpha minus 17. Yes. So if you move it to the left, it becomes positive. So if you substitute this times 3 minus 17, so 15 minus 17 is minus 2. So our beta is minus 2. So let's go over to the original expression. They told us that R is alpha m. Alpha is 3, so I have 3m. Y beta is minus 2, we have minus 2n. Therefore, we are asked to make n the subject of formula. So making n the subject of formula, this comes over to be 2n. This goes over there to be minus r. Therefore, n is now half 3m minus r. So that's what we are asked to solve. So it's a nice and tricky question. Thank you.